Let's take a look at this question, which can be solved either using binomial distribution or Poisson distribution. Okay, so binomial and Poisson are similar. They both only have two options, success or failure. In both Poisson and binomial, you still have independence. So here, in this case, getting cancer does not depend on anybody else getting cancer. The difference is in binomial, you have a fixed number of trials, where in Poisson, you have an infinite number of trials. Okay, so that's the big difference. The idea here is that we're trying to see if number of men out of 9,500 getting cancer, what the probability of this is. Okay, so here we'll solve it first using binomial. So let x be the number of linemen with cancer. Then x is a binomial where the fixed number is 9,500, and the probability of getting cancer, it says here, is 1 in a million, so 1 out of a million. Okay, this is binomial if we consider the number of men, 9,500, to be an exact replicate of numbers. Often when somebody's saying a statement like this and they say, well, how many employees do you have? Well, about 9,500. Okay, here we're seeing that this number is so large, it's starting to approach, like, infinity-ish. Okay, we could do this as a Poisson, so we'll see that a little bit later. So what's the probability of having the number of linemen with cancer be more than or equal to 2? Okay, so I've just written it out here. You could have 0, 1, 2, 3, or all 9,500 with cancer. So greater than or equal to 2 would be 2 plus 3 plus 4, all the way up to here, this 9,500. Okay, so this could be written as the probability of x being greater than or equal to 2, or we can focus on the complement here, 1 minus the probability of 1 or fewer, okay, at least 1. Either way, this will give us the same number. Okay, so I'm going to use the computer to calculate this as a binomial probability. Okay, so 1 minus, in this case, Minitab only knows the less than or equal to sign, so less than or equal to 1. Okay, so we'll go to calc, probability distribution, binomial. This is a cumulative, so it's including everything lower than and equaling 1. Okay, so that's cumulative probability. The number of trials, 9,500, and the event probability was 1 divided out of a million, or 5 zeros and then a 1 if you carry that out. And we want less than or equal to 1. Here I get the probability of less than or equal to 1 being 0.49s and then 2 5s. So 1 minus 0.49s and 2 5s gives me a probability very close to 0 of having at least 2 linemen with cancer. Okay, so the other way I could think about this, like I said, was as a Poisson distribution. Here, Poissons are always given as rates. Okay, so here, instead of focusing on the probability of cancer being 1 out of a million, let's say that what we're going to do here is put 9,500 out of a million. Okay, so then that gives us this rate here. Okay, so when I calculate this with this rate, what I find, of course, I could say this, if x was a Poisson, it's still the number of linesmen with cancer. But here we've got 1 minus x is less than or equal to 1, 1 minus x is equal to 0, or minus 1 equal to 1. Okay, so I could write this out using the Poisson distribution formula, okay, as I've done here. Or again, I can use Minitab if I like to say this is calculate the probability distribution of a Poisson, where yes, I'm still doing the cumulative probability. The mean, or the lambda, or the rate we said here was 0.0095. And again, we're finding less than or equal to 1. We find here that this, of course, is the exact same probability we found when doing it as a binomial. So this is 1 minus 0.49s and 2 5s. Again, of course, we get the probability of having at least 2 to be the same, either way we calculate.